All right. For some of you, today is going to be really confusing. There is not just one way to answer these. They can all be done two ways pretty easily, or three or four or five or 10. There are a lot of different ways to do them. So you just have to take all of the rules from trigonometry and blend them all together and make it work. So before we get started, let me remind you of a couple things. The sine of theta is defined as what two sides? Opposite divided by hypotenuse. And you should be able to remember that from SOHCAHTOA. So the cosine of theta is equal to adjacent over hypotenuse, and the tangent of theta is equal to opposite over adjacent. Now, those are the buttons on your calculator you use if you know the angle. So right here, we have theta listed. If you know theta, then you can list the opposite and the adjacent and hypotenuse and so on. So looking at this triangle over there to the right, what is the sine of A? So here's theta. Sine is opposite over hypotenuse. So it would be little a divided by little c, a over c. What would the tangent of B equal? So for that one, we have to move theta to the other side. Tangent is O divided by A, so B over A. That would be the tangent of B. Now, that's if you are looking at the angle. Sometimes we don't know what the angle is, and we need to find it by using the inverse. So at any time, you can switch these and change the tangent to the tangent inverse. So the tangent inverse of B over A is equal to angle B. And that's going to be very valuable today. If you know what theta is, then you're going to use the sine, the cosine, of the tangent. If you are using the ratio, then you use the inverse sine or inverse cosine or inverse tangent. Okay? So if I told you that B equaled the adjacent side, where is theta? So over here on this triangle, if I told you that this is the adjacent, where's theta? Is theta up here at A, or is it over here at B? Have to be there. Okay? So if I told you that this is the opposite side, where is theta? So if this is the opposite, theta would be over here at A. Okay? So wherever theta is, adjacent means it touches, opposite means it doesn't touch, and C is always the hypotenuse. All right? So pay close attention to this, because it is going to be confusing. I'll work all the problems on the front side, and then it's your job to do the back side. Starting with letter A. If the cosine of A equals 4 over 5, what does the sine of A equal? So here's theta, and the cosine of A is 4 over 5. Where do I put the 4 and where do I put the 5 on the triangle? Well, cosine is A over H, so 4 must be adjacent and 5 must be hypotenuse. Does everybody get that? So what side of the triangle gets the 4? A, B, or C? What is the adjacent to angle A? B. So this is 4 and this is 5. Everybody get that? So I need to figure out what angle A is. If I switch these, I need to use the cosine inverse of 4/5 equals angle A. So the original problem told me the sides, and I need to know what the angle is. So I switch the ratio and the angle, and I use the inverse. So in your calculators, type in the inverse cosine of 4/5. Oh, inverse cosine. I pushed the wrong button. What does that tell me? Angle A is 36.86 degrees. So angle A equals 36.86. Well, the problem asks me to calculate the sine of A. So all I have to do is plug 36.86 into the sine. So sine, and you could type all that in the long way or just push second. The negative button is answer. Second answer will give me 0.6. So the sine of A is 0.6. Letter B. If the sine of A is 0.6, what is the cosine of B? So over here, here's theta. The sine of A is 0.6. What is the cosine of B? So I need to switch the angle and the ratio using, what button on my calculator do I push? Well, it's the sine, but when I switch them, it's the sine inverse of 0.6. So sine inverse of 0.6 equals 36.86 degrees. So that's the measure of A, 36.86 degrees. What does the problem want me to calculate? It wants me to calculate the cosine of B, but I don't know what angle B equals. How do I calculate angle B? Well, it's a triangle. All three sides add up to 180, and one of them is 90. So what do I know about these two angles? Together, they have to add up to be, well, all three of them add up to be 180, but this one's already 90 degrees. So there's only 90 degrees left over, so A and B add up to 90. If A is 36.86, then I can calculate B by doing 90 minus the answer, and that's angle B, 53.13, and it wants me to calculate the cosine of B, so I'm just going to type in the cosine of the answer. Which is 0.6. Now, isn't that what we started with? This problem says the sine of A is 0.6, and we just proved that the cosine of B is also 0.6, which makes sense, because if this is theta, the sine of theta is A divided by C. But if I move my theta to the other side, and then I do the cosine, I still get A over C. So one thing that you should remember that will always work, the sine of A is equal to the cosine of B every time, or the other way around. The sine of B is equal to the cosine of A. So in this problem, it says the sine of A is 0.6. What is the cosine of B? Well, those two will always be the same. So if you see this problem on a test, which you might, you can just say, oh, the sine of A and the cosine of B are the same thing, so the answer is 0.6. All right, letter C. The cosine of A is 0.32. What is the tangent of A? Well, let's reverse these. Cosine inverse of 0.32 is equal to angle A. So in your calculator, cosine inverse of 0.32, that gives me 71 degrees. And the problem is asking for the tangent of A. So I'm just going to type in tangent of answer. And I get 2.96. Are you kind of getting the hang of this? No? All right, let's do some more. If you have a question, please let me know. Letter D. The tangent of B is 2.5. What is the cosine of A? So I'm going to invert. I'm going to switch these. Tangent inverse of 2.5 gives me 68.19. What angle is that? So angle B equals 68.19, and I want the cosine of A. I don't know what A is. How do I figure it out? Not yet. So we inverted the tangent to find the angle B. So we know that this angle here is 68.19. But I don't want the cosine of B, I want the cosine of A. If I know angle B, how do I figure out angle A? Well, we know that A and B add up to 90. All three angles add up to 180. We know that this one is 90, so 180 minus 90 is 90. A and B add up to 90, so I need to type in 90 minus the answer. That tells me that angle A is 21.8 degrees. And now I can calculate the cosine of A. So cosine of the answer is 0.92. All right, letter E. If the cosine of A is 1.2, what is the tangent of B? I can calculate angle A by doing the inverse cosine. So second cosine inverse of 1.2. And I get error. Well, the reason that's an error, the cosine of A equals 1.2. So that's a fraction there would be like 12 over 10. And cosine is A over H. Is it possible for A to equal 12 and H to equal 10? Why not? H has to be the longest side, so the calculator is telling me there is no angle that works. There is no angle that will make A larger than H. So this one has no solution. There is no right triangle that satisfies that. All right, letter F. If the sine of A is 2.5, what is the measure of B? Or sorry, 2/5. If the sine of A is 2/5, what is the measure of B? So we can switch these. Sine inverse of 2/5 will tell us how big angle A is. So the sine inverse of 2/5 gives me 23.57 degrees. What is the measure of angle B? How would I calculate B? Well, I know that A is 23.57. What do I know about A and B? They're not the same. They add up to 90. 90 minus angle A is going to tell us angle B is 66.42. Okay, letter G. If the tangent of B is 0.75, what is the measure of angle B? If I invert this, I have the tangent inverse of 0.75 will tell me angle B, and that's what I want to know. So all you have to do is type this one in and you'll get the answer. So the inverse tangent of 0.75 is 36.86 degrees. And we're done. Okay. Letter H. If the sine inverse of A over C equals 21 degrees, what is the cosine of B? This seems really tricky until you understand what it's asking, and then it's not any harder. You just have to say the sine of theta equals O divided by H. Everybody understands that, right? So, little a is the opposite side, and C is the hypotenuse. If we take a look at our triangle, little a is opposite, and C is hypotenuse. Where is theta? Angle A or angle B? If I put theta here, does that satisfy the opposite side? No. Little a would be adjacent. So angle A is theta. Do we know how big angle A is? Look at the problem. It says when we do the inverse sine of A divided by C, I get 21 degrees. So A is 21 degrees. The problem wants us to find the cosine of B. Do I know what the cosine of B equals? Hang on. What is the measure of angle B? How would I find? Yeah, A and B add up to 90. So 90 minus 21 is 69 degrees. And what do I do to that? Well, it's asking for the cosine of B. So the cosine of 69 is 0.35. Or, Caitlin, how else could we have solved that? Meaning, instead of finding the cosine of B, I actually could have just plugged in the sine of A. I know what this angle is. The sine would be A over C. The cosine of B is also A over C. So if I type in the sine of 21, it should be the same ratio. 0.35. Letter I. The cosine inverse of A over C equals 74. What is the length of C? Cosine is defined as A adjacent over hypotenuse. So the adjacent side is A, and the hypotenuse is C. So little a is the adjacent, and this is the hypotenuse. Where do I put theta? B is theta. So theta is 74 degrees. If I know that that angle is 74 degrees, how big is the hypotenuse? And you should see a problem. all we know about this triangle is that there's a 74-degree angle right there. How many right triangles are there with a 74-degree angle? Well, there's one. Here's another one. Here's another one. We have no idea how big this triangle is. All we know is the ratio, which gives us the angle, and that angle could be attached to an infinite number of triangles. So in order to know how big C is, we need to know one of the other sides, which they didn't give us. So anytime you're dealing a trig problem, there are three parts. There's an angle and two sides. If you know two of those, you can figure out the third. If you know two sides, you can figure out the angle. If you know the angle on one side, you can find the other sides. But if all you know is the angle, you can't tell how big the triangle is. Likewise, if all you know is one side, you can't tell anything else about those sides or the angles. Well, yeah, you know that one angle is 90, right? So that one doesn't have an answer. We don't have enough information. So if you look at letter J, this has a 74-degree angle, but it doesn't ask for the angle or side. It asks for the angle. So tangent is defined as opposite over adjacent. So little b is the opposite and little a is the adjacent. If little b is the opposite and a is the adjacent, where is theta? B is theta, and that gets the 74-degree mark. Now instead of asking for a side, it asks for angle A. Can we figure out the size of angle A? Yes. How do A and B relate to each other? They equal 90, so 74 plus what is 90? 16 degrees. So angle A is 16 degrees. Letter K. This one's kind of tricky. If the cosine of 13 degrees is 0.97, what is the sine of 25? If the cosine of 13 degrees is 0.97, what is the sine of 25? Well, does the sine of 13 have anything to do with the cosine of 25? Those are two different triangles. This information is not needed. What is the sine of 25? Well, we just type in the sine of 25. 0.42. So you don't necessarily have to use everything that's given. Sometimes you need it, sometimes you don't. Yeah, so that was unneeded information. And last one, letter L. If the sine inverse of A over C equals 20 degrees, what is the measure of angle B? What is the definition of sine? Opposite over hypotenuse. So opposite is A and hypotenuse is C. I can label those on the triangle. A is opposite and C is the hypotenuse. Where is theta? Angle A is theta, so this angle is 20 degrees. And the question asks for the measure of angle B. How big is B? Close. 70. So angle B equals 70 degrees. The answers are on the back of this worksheet, but in order to receive credit, you need to show your work like we've been doing on all of these problems. If you just write the answers, we're not going to give you any credit. Good luck.